So problem 54, we're given a circuit with a bunch of resistors here and a switch. We are told that when the switch is thrown, the equivalent resistance is equal to half of the equivalent resistance when it's open. Right? And then we're asked to find the value of R. So what we need to do is find the equivalent resistance of both scenarios. So when this is open and when this is closed. So let's start with it open. All right, so equivalent resistance open is going to be, well, we have this R here. This is in series. Let's use the green. It's a little easier to see. This is going to be in series with, we'll sum these up, right? Let's do this. Let's start first with taking this one and this one are in series, right? This one and this one are in series, and then we'll sum them up in parallel as well. So we have R plus, now we have something in parallel. It's going to be this one and this one in series is 100, so this is 1 over 100 ohms plus, since these two are in parallel, we're adding them up. So this is in series, this is in series. We add these two things in parallel then, right? So 90 plus 10 is 100. 90 plus 10 is 100. Then we add 1 over 100, 1 over 100 here. And that's inverse. Okay? And that's kind of it for that one. So then we just sum it up, right? So then we have 2 over 100 inverse, and then this is going to be 50 ohms. R plus 50 ohms is the equivalent resistance when the switch is open. Okay, so now when the switch is closed. So if the switch is closed here, now we have a little bit of a different scenario. Now we have this one and this one are in parallel, and this one are in parallel. Okay, so we'll add these up. Oops. Switch is closed, right? And this is going to be equal to R, remember, because we just have this one R sitting over here. R plus, and then we're actually going to have two of these, because we have these two things in parallel, and then these two things are in parallel. So that's actually going to give us a factor of 2 times 1 over 10 plus 1 over 90. This is inverse, right? Because, okay, so what we're doing is we're taking 90 plus 10 in parallel, 1 over 90 plus 1 over 10, and then we're going to have a factor of 2 of those. And then what we end up with is right, and that gives us a value of R plus 2. 2 times 9, so that's R plus 18 ohms. Just before I move on, I want to explain that just a little bit better. So again, we're taking these two things in parallel, right? 1 over 90 plus 1 over 10. This is also 1 over 10 plus 1 over 90. And these happen to be in sequence with each other. So this is going to, or in series with each other. So we have a current that would flow this way. And if we redrew this, come this way, and then we have essentially two of the same in series. Okay? And for this one here, I took something like this, and then we ended up with 2 times 1 over 90. One over 90 plus 9 over 90, right? So that's how I got 10 over 90, just to be explicit about what I'm doing. Okay, and recall that this, we were told in the beginning that this is actually equal to half of the original equivalent resistance. Okay, so then what does that mean? That means that we have, let's see, how do we want to write this? Let's write R equivalent is equal to what we found earlier, R plus 50 ohms, and that's going to equal 2R plus 36 ohms, because I'm just taking this factor of 2 times the 2R. It's my dog. So we just take this factor of 2 times 2R, 2 times R, 2 times 18. This is what we end up with. Now we're just solving for R, right? So this gives us R when we have plus R is equal to 14 ohms, right? We take the difference here and the difference here. So just taking those the other side, that's what we end up with.